Hey everyone, welcome to physics. We are in Unit 1, Intro to Kinematics. We've seen most of these terms before, but we're putting them in a slightly different context, so it'll be a little more exciting for us. But we're looking at speed, Unit 1 speed here. And the first things we talk about is what is distance. So we all know what the distance between two objects, but what is it? We have an interesting definition here. What is distance? And a lot of times what we're hung up on is what the definition of things are. And so what's important is to define what is distance or what is length. And so in our definitions, we can't use the words distance or length or anything like that. You can't use those terms to define the term, right? So if you think about it, it's pretty difficult to define what that actually is. Distance is a fundamental part of nature, so it is so fundamental that it's almost impossible to define, but everyone knows what it is. It's like those things that we talked about earlier. In geometry, we have undefined terms like points and lines, and those things don't exist, but we use them to describe other things. That's how we use distance. We can compare distances, however. We can compare distances because we know we can measure them using a comparison. So we create a standard distances that we can easily make those comparisons and tell someone else about them. That standard we use will be the meter. The meter is going to be used for our measuring distance. And we all know what a meter stick is. We used them for our little rope measuring activity. But once again, this doesn't define distance, but it does allow us to work with it. And that's an important aspect of what we're looking at here. So once again, we'll be using the meter for our standard measuring distance. The symbol most commonly used is D, but we also can use X, we can use subscripts, so there's lots of different ways we can describe the distance, D. The unit is the meter, M is what we'll use. So here's a quick example. We have a little meter stick, and 20 centimeters, D equals 0.2 meters, 0.2 meters. So that's what we'll be using there. The other thing we look at is time. Similarly, everyone knows what time is, but what is it? How do we define it? What is time? Remember, we can't use time or any equivalent in your definition. So like distance, time is a fundamental aspect of nature. It's very difficult to define it, but we know what it is. We can compare things, like we know how long a year is, how long a day is. We use it to compare like a post and pre condition. That's what we're going to be using. We can say that in the time it took to run the track, the second hand went around the watch once, so the run took 60 seconds. We compare the time between the two events to the time between other two events. We are measuring time. It might take you longer or shorter to run that thing. Once again, it doesn't define time, but it does allow us to work with it. We will be using the second as our standard measuring device for time. We use the symbol T. Once again, the unit for a second is S. That's the variable we'll be using. And so here's our clock. It takes 10 seconds for the red second hand to roll that way. So that's fairly straightforward. Then we talk about speed. I know you guys have discussed speed in other classes before. Speed is defined as the distance traveled by the time it took to travel that distance. So speed is distance divided by time, and in variable format, S equals D over T. Speed is not a fundamental aspect of nature. It is actually the ratio of two things that are fundamental aspects. So we have this ratio of distance to time, two fundamental things. But now we can all of a sudden define what speed is. It's the ratio of those two values, which is kind of cool. The units of speed can be seen by substituting the units for distance and time into the equation. So here's my equation, S equals D over T. The units for distance is meters, and the units for time is seconds. Meters divided by second, which is a meter divided by second. And we read this as a meters per second. So that's important to make sure we understand how to read those things. I think we're pretty straight on that. And then everyone's favorite thing that we talk about is word problems. And so the vast majority of the types of questions that we see are essentially word questions. And so here's a pretty good approach on how you end up solving, how you solve these things. And so there's just not necessarily a formula for each one of these. Yes, we use formulas, but every one of these questions can be done a variety of ways. So this is just a good general approach to how we do things. Sometimes drawing and labeling diagrams are easier in some situations than others, but sketching things out, writing down givens, those are all good strategies to use for this. So there we go. So a quick example, I have a couple of examples here how to solve the word problems. So we're working with our same basic equations. So these aren't numerically difficult. Like the math isn't hard, but the process is super important. That's the thing that I'm trying to make sure we get across today. So we have a car traveling 50 meters in 20 seconds. What is its speed? One of the first things I always try to do is I always try to write the givens. I know the distance is 50 meters, the time is 20 seconds, and it just helps me sift through the information. I'm looking for the speed, so I don't know S. But my equation here is S equals D over T. And once I have that information, I just go ahead and plug everything in. So I have 50 meters divided by 20 seconds. And then I run the math and I get 2.5 meters per second. Notice the units match up with what I'm looking for. And then what we do is I want us to write a little sentence, grammatically correct. I want our English teachers happy with us. So here the car traveled 50 meters in 20 seconds at 2.5 meters per second. So we need to be able to write a physical description of the actual thing that's going on. That's going to be important for this class. Next example, still looking at speed, but I have a couple of different variables that I know now. So the speed is 3 meters per second. The time is 2.5 seconds. So there's my givens. I don't know D, so I'll put a little question mark next to there if I remember. But here, I have S equals D over T. That's the original thing I start with, but now I have to solve for D. So the second line there says D equals S times T. Plug everything in, 3 meters per second times 2.5 seconds. Notice the units, the seconds end up canceling, leaving me with 7.5 meters. That's what I was looking for, how far I traveled. And then the sentence for this, the ball rolled 7.5 meters for 2.5 seconds at a speed of 3 meters per second. So once again, making sure all that information there is important. All right, last example here, we have something that we know will have a distance traveled of 150 meters and a speed of 30 meters per second. So once again, here are my givens, D and V, 150 meters and 30 meters per second respectively, with my unknown T. Once again, starting with S equals D over T, we solve for T. So T equals D over S. The T and the S essentially switch places. We have 150 meters divided by 30 meters per second. And so we have a little math rule that makes the units work. And I'll show you guys what that means. And once again, everything kind of just falls back on math here. But we get 5 seconds for this, 150 divided by 30. And my sentence for this is it takes 5 seconds to travel 150 meters at 30 meters per second. So once again, writing that little sentence there to describe the physical thing that's going on. All right, that's it. Come to class and we will have the problem sets and some stuff to work on. Thanks for watching. Talk to you guys later. Bye.